Our mission is to install a moon camp in a lunar lava tube in compliance with the UN Moon Agreement. The name of the camp is Petralona, which is one of the oldest caves used by prehistoric man in Europe. Establishing the first extraterrestrial human settlement will be an initial step for expanding man's activities in the solar system, and it will serve as mankind's next giant leap. As pictured by a mission of the Japanese Aerospace Exploration Agency, this is Marius Hills, in which our moon camp will be located, inside a lava tube. On moon's surface, dust, solar wind and static electricity of hundreds of volts as in polar craters, along with extreme alternating temperatures between 127 degrees Celsius and minus 173 degrees Celsius, will wear down the health of the crew, electronic devices, solar panels and other machinery. Significant operational, technological and economical benefits result if a lunar base is constructed inside a lava tube. Our camp will be airtightly shielded from the surface environment in order to offer habitable circumstances inside with steady mild temperatures around 17 degrees Celsius. Moreover, the whole internal outpost will be filled with breathable air pressurized at one atom and connected through pipeline with a region rich in water and volatiles. The roof of the selected lava tube is almost 25 meters and thus it provides absolute protection against micrometeoroids, meteorites and cosmic radiation, since the conventional radiation shield is only partially effective. It is also safe against moonquakes and has sturdy properties. Furthermore, being at the near the Earth side at the equator level makes communication with Earth unimpeded, protecting the crew from any emergencies. Due to the protected environment and maximal thermal insulation, the energy requirements are reduced, the production of food will be easier, experimental farming and regolith cultivation feasible, and the needs for water, air and power smaller and economical. At preparation phase, terrestrial material will have to be carried, including unit of oxygen and water production and recycling, solar panels and charged batteries, aluminium, carbon fibers, mining crane, 2 robotic rovers, antennas, 3D printer, small quantities of oxygen, nitrogen and hydrogen. After leveling the floor with a debris moving operation with 3D printing using lunar soil and regolith casts, we will immediately start the construction of permanent habitats. The selected segment of the lava cave will become shielded from the surface by airtightly sealing the skylight and then blocking the lumen of the tunnel on either side by building airtight walls. Fenestrations will be opened on the roof, shielded with transparent ceramic from aluminium oxynitride for natural illumination the day period. This is a dome structure protected from radiation by a 2-meter thick regolith cover and has ceramic windows to allow sky observation. It serves as the main entrance for crew and vehicles through an airlock module. On the surface will also be a launch pad, the solar plates, and a protective shell with an emergent escape rocket. Our permanent moon camp is consisted of a central tower containing 1 elevator for heavy loads, cargo cars, and 1 for personnel. At the base of the tower, habitats made of durable lightweight materials will be connected together through airlock modules parallel to the ground. By connecting extra modules, the habitable lunar base can be expanded incrementally and in case of a damaged module could simply be isolated from the rest by closing the shared hatches. Paleoregolith mines will also be created. Outside the walls in the tunnel will be the fuel tanks and the nuclear power plant and paleoregolith mines. A ramp from the surface to the tunnel floor will be an alternative access apart from the elevators. The location of the camp and the abundance of room permits the habitats to be of simple, low-cost orthogonal design. These include the common leisure and activities place and private rooms for each person, energy storage, electrolyzer, room for recycling systems, greenhouse, laboratories, medical facilities, a control and communication center, maintenance garage and storage place for spare parts and construction equipment, and regolith processing.